Good day, friends, and you are again welcome to another Wase online experience. My name is Philip, and I'll be your instructor for today. But before we start our activity for the day, I'll need you to subscribe to our channel if you've not already done that. Remember, once new videos are created, you'll be sent an alert if you have subscribed to this channel. To be able to do this, you simply need to go below the video and tap the subscribe button. Alright, thank you very much for doing this for us. Let's look at our activity for the day. Today, under set and set operations, we'll be looking at part 7. And under part 7, we'll be looking at how to solve some practical problems using Venn diagram. And here we'll focus on 3 set problems. I believe we can start our activity for today. Now, we are done with 2 set problems. Let's look at 3 set problems. Before we start looking at real problems, let's quickly go through various shaded regions of the 3 set Venn diagram. So this is our Venn diagram of 3 intersecting sets. So for this Venn diagram, we have the 3 sets: set A, set B, and set C. Let's assume that set A represents number of students that like apple, and set B represents number of students that like banana, while set C is the number of students that like cocoyam. So let's assume these 3 sets represent these various groups of people in a classroom. As you can see from this Venn diagram of 3 intersecting sets, we have 8 different regions, and each of these regions are represented by numbers. Now the numbers tell us the number of students in each of the regions. So for example, when you take the number 3, it tells us that we have 3 students representing that region. When you take the number 7, it tells us that we have 7 students representing that region. When you take the number 6, that tells us that we have 6 students representing that region. We are going to take the regions one after the other and we will discuss them. Also, we are going to put some of the regions together and also discuss those groups of regions together. So let's start by looking at them from the first groups of regions. We would first look at the total number of students in this class. Remember, we said that this Venn diagram of 3 intersecting sets has 3 different groups of people in a class: those that like apple, those that like banana, and those that like cocoyam. So we are going to first look at the total number of people in this class. Now, to find the total number of people or students in this class, all we need to do is to add all the various regions together. So we would add region 1 to region 2 to 3 to 4 to 5 to 6 to 7 and to region 8. We would add all of those regions together, and the total would give us the total number of students in that class. So let's quickly do that. So we have 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7 plus 8. When you put all of them together, you get 36. So what this means is that we have a total of 36 students or people in this class. So let's look at the next group of regions. So let's look at the next example. We are using the same Venn diagram. At this stage, we want to know the number of students from this class that eat apples. Let's remember that we said apples are being represented by the set A or by the circle A. So the easiest way to go about this is to identify the circle A. So let's quickly identify the circle A, which is apple. This is the set representing A or apples, or number of students that like apples. From this circle, you would realize that to find the number of students that eat apples, you would have to add all the various regions or all the various areas together. So we have 1 plus 2 plus 4 and plus 6. We would have to add all of those regions together to get the number of students that eat apples. So let's write that information down. So we have 1 plus 2 plus 4 plus 6. That would give us 13. So what this means is that 13, or a total of 13 of these students eat apples. Now you realize that from the diagram, amongst those who eat apple, 13 in number, there are some that although eat apples would eat other foods. Let's take the number 4 for example. The number 4, he eats apple, but he's also eating something else apart from the apple. He's eating cocoyam. When you take the number 2, these people are eating apples, but at the same time they are also eating bananas. When you take the number 1, this group, they are eating apples, they are also eating bananas, and they are also eating cocoyams at the same time. So I need you to note these individual groups that come together to give us the total sum of apples. So remember, the 6 here represent those who are eating only apple. They eat only apple without any other thing. Therefore, this group of people eat apples and they also eat cocoyams. Then the one, they eat apples, they eat cocoyam, and they eat bananas. And those 2 in number, they eat apples and they also eat bananas. So you need to remember these regions. But remember that when we add all of them together, they all eat apples. So let's note this. Let's move on to the next set of items. For this set, we'll be looking at those individuals in this class who eat banana. So let's look at them. So we said banana will be represented by the circle B or the set B. This is the circle B or the set B. It represents all the students in the class that eat banana. So if we want to find the number of students in the class that eat banana, you would have to add the various regions within that circle B together. So that will be 1 plus 2 plus 3 plus 5. We would have to add all of them together to find out about the number of students in the class that eat banana. So let's quickly do that. So we have 1 plus 2 plus 3 plus 5. That will give us 11. This means that 11 students from this particular class eat banana. Again, I need us to note that you realize that banana has various regions that came together to form it. So we have the region 1, 2, and 3, and the region 5. All of them came together to give us the number of students that eat banana. Amongst these regions, we have those that eat only banana. For example, the region 5, they only eat banana and nothing else. When you take those in the region 2, this group of people eat banana, but aside banana, they also eat apples. Now when you go to those in the region 3, you realize that these people, they eat banana alright, but those in the region 3 also eat cocoyam aside eating banana. Then finally, those in the region 1, they eat banana, and together with banana, they are also eating, or they also eat apples and cocoyam. So I will need you to take notice of this. So remember that, but when we add all of those groups of people together, all of them give us a number of 11, which eats banana. So let's move on to the next item. Now let's look at the number of students that eat cocoyam. First, let's remember that the circle C, or the set C, is representing the number of students that eat cocoyam. So to find the total number of students that eat cocoyam, we would have to identify the circle C. So that's our circle C. To find the total number of students that eat cocoyam, we would have to add the various regions in C, or circle C, or set C together. So that will be 1 plus 3 plus 4 plus 7. And when you add 1 plus 3 plus 4 plus 7, you would get 15. 15 is the total number of students that eat cocoyam. Again, from the number of people that eat cocoyam, some of them eat cocoyam alone, those in group 7, or those who are 7 in number. These 7 people eat only cocoyam. Apart from cocoyam, they do not eat any other thing. The 4 in number, those who are 4 in number, they are eating cocoyam alright, but in addition to cocoyam, they eat apples. So the 3 people in the circle, they eat cocoyam, but at the same time they also eat bananas. Then that one person in the center, he eats cocoyam, but in addition to cocoyam, he eats bananas and apples. So we need to note these as well. It's very important. Now let's move on to the next group. Now let's look at set A intersection B. This region is the region where the set, or the circle A, interlock with the circle or set B. This is the area or region A intersection B. As you can see from the diagram, the 2 circles A and B interlocked at this region. This region represents the number of people or students who eat apples and bananas at the same time. So if you have to find the number of students who eat apples and bananas at the same time, it is this region you have to look out for. As you can see, we have 2 main regions that come together to form this region. So you would have to add the numbers of students in each of those 2 regions together to get this region A intersection B. So what we will do is we will add the number 1 to the number 2, and that would give us the number of students that eat apples and bananas at the same time, which is the same as A intersection B. So let's quickly do that. So we have 1 plus 2, which is equals to 3 students. Now let's note that among these people who eat apples and bananas at the same time, we have two main groups of them, those in group 1 and those in group 2. Those in group 1, apart from eating apples and bananas at the same time, would also eat another item. So as you can see, those in group 1 are also eating cocoyams. So they are eating apples and banana, but they are eating cocoyams as well. While those in 2, the 2 in number, those people eat only apples and bananas, or they only eat apples and only apples and bananas. So let's differentiate between the two regions. Next, we'll be looking at A intersection C. This is the region where the circle A and the circle C interlock or intersect. This is the area or region representing A intersection C. The people in this area, or the student in this area, eat apples and cocoyams. Now, so you need to first note that. Secondly, you need to note that two groups of people come together to form this area or this group. First, we have those who eat only apples and cocoyams. That's the number 4. They are 4 in number. They eat only apples and cocoyams. Apart from apples and cocoyams only, they do not eat any other thing. Then we have the one person in the middle. He eats apples and cocoyam, but at the same time he also eats bananas. Remember, the two are brought together to form A intersection B, which is number of people eating or students eating apples and cocoyam at the same time. So that will be 1 plus 4. What would that give us? That will give us 5. So let's quickly do that. So 5 people eat apples and cocoyams. Let's look for the next item. We have B intersection C. B intersection C is the region where the circle B or banana intersects with the circle C, cocoyam. This is the region B intersection C. The students in this region eat bananas and cocoyam. Also, you realize that two groups of people or students are in this region. We have those that eat only bananas and cocoyam. They are 3 in number. And we also have one person that eats bananas and cocoyams, alright. But in addition, he will also eat apples. So those are the two groups of people that form this region. So to find the number of people in this region, you would have to add 1 to 3 to get that answer. Let's quickly do this. So we have 1 plus 3, that will give us 4, which means that 4 people from the class eat bananas and cocoyam. Out of these 4 people, 3 of them eat bananas and cocoyams only, and one person, in addition to bananas and cocoyams, would also eat apples. Now let's look for the people in the class who eat everything. They will eat apples, they will eat bananas, they will eat cocoyams. Let's identify them in the Venn diagram. So this region represents those people. So as you can see from the diagram, we have only one person in this group. He would eat apples, bananas and cocoyams. So let's write that information down. Let's move to the next item. Now let's look for the number of students who eat 2 foods only. 2 foods only. At any point in time, they will eat 2 foods. So these 3 regions represent those people in the class who eat 2 foods only. For those in group 2, they eat apples and bananas only. For those in group 4, they eat apples and cocoyams only. And for those in group 3, they eat bananas and cocoyams only. So when we add all of them together, it gives us the sum of students who eat 2 foods only. So we have 2 plus 3 plus 4. 2 plus 3 plus 4 will give us 9. Therefore, 9 students eat 2 foods only. Now, let's look for the number of students that eat 1 food only. These are the students that eat 1 food only. Those in group 5 eat only bananas. Those in group 6 eat only apples. And those in group 7 eat only cocoyams. So if you want to find the number of students who eat only one item, you have to add these numbers together because they are one item each. So you have to add all of them together to get the answer. So that will be 5 plus 6 plus 7. So we have 5 plus 6 plus 7. Everything added together would give us 18. Therefore, the number of students that eat only one item is 18. Now let's look at the number of students that do not eat any of the fruits. These students would not eat apples, they would not eat bananas, and they would not eat cocoyams. What this means is that they will be outside those 3 circles, but of course they are still in the class. So although they are outside those 3 circles, they should still be in the class. Remember, the class is our universal set, which is being represented by the rectangle. So this region is the region that is outside the 3 circles but is in the rectangle. This is the region 8. So what it means is that the number of students who do not like any of the foods is equals to 8. So let's look at the first example under 3 set problems, and I'll read the question. The Venn diagram below shows the result of interviewing some students at a school. B is a set of students who play baseball. H is a set of students who play hockey. and T is the set of students who play tennis. A. How many students were interviewed? B. How many students played tennis? C. How many students played baseball? D. How many students played hockey? E. How many students played only 2 sports? F. How many students played only 1 sport? G. How many students played all 3 sports? So that's the question given to us, and that's the diagram we are supposed to use to solve this problem. So we'll be going to a fresh page with the information given to us on the Venn diagram, and we are going to use this information to solve the following problems presented to us. So let's start with the solution to the problem given to us. This is the Venn diagram with the details that would enable us solve this problem. For the first question, we are to find how many students were interviewed. The number of those interviewed is the universal set, and to get this we would have to add all the people within the universal set, all the various groups of people within the universal set. So let's quickly do this. So you would add 12 to 6 to 18 to 4 to 3 to 7 to 23 and to 10. We would add all of these figures together, and that would give us the total number of students who were interviewed. When we do this, we would get 83. So therefore 83 students were interviewed. The second question: how many students played tennis? So that's the second question. So this is the circle that represents tennis. To get the number of students that played tennis, we would have to add the various groups of students from this group. So we would have to add 4 to 3, then to 7, then to 23 to get the number of people who played tennis. So let's quickly do this. So we have 4 plus 3 plus 7 plus 23. When you do the addition, you get 37, which means that we have 37 students played tennis. So that's the answer for the B. Let's look at the question C, and it says that how many students played baseball. To do this, we first need to identify the circle that represents baseball. This is the circle that represents baseball. So we would add the numbers in this circle, which means that we would have 12 plus 6 plus 3, then plus 4. We would add all of these numbers together, and when we do that, we get 25. Therefore 25 students played baseball. Question D, and I read, how many students played hockey? As usual, we would first identify the hockey circle. This is the circle representing hockey. To get the number of students who played hockey, we would have to add the numbers within this circle. So you would add 6 to 3, then to 7, then to 18. When you add these four numbers, you would get 34. Therefore, 34 students played hockey. Let's look at the next question. How many students played only 2 sports? So first, let's identify the regions that represent only 2 sports. So these are the regions that represent only 2 sports. The region with the 6 people is the region that represents those who only play baseball and hockey, whilst the region with the 4 people is the region that represents those that play baseball and tennis only, and the region with the 7 people represent those who play only hockey and tennis. So those are the only regions with people who play only 2 sports. So you would have to add them together to get the total number of students who play only 2 sports. So we have 6 plus 4 plus 7. When you do the simple arithmetic, you get 17. Therefore, 17 students played only 2 sports. Now let's look at how many students played only 1 sport. To do this, we would first need to identify the regions on the Venn diagram where students played only 1 sport. Then afterwards, we would add all of those individual regions together to get the answer. So let's look for those regions. So these regions represent students who played only 1 sport. The region with the 12 people is the region where students play only baseball. The region with the 18 people is the region where students play only hockey. And the region with 23 students is the region where students play only tennis. So we would add these 3 regions together. So we have 12 plus 18 plus 23, and that will give us 53. So 53 students played only 1 sport. For question G, how many students played all 3 sports? First, we would identify the region where students played all 3 sports. So this is the region where students played all 3 sports. And here the answer is very clear. 3 students played all 3 sports. Let's look at question H. How many students do not play any of the 3 sports? As you can see from the Venn diagram, The number 10 is in the region where students do not play any of the sports. Therefore, 10 students do not play any of the sports. Let's look at example 2. In a class of 45 students, 24 read math and 20 read English. 22 read history. 3 read all subjects. 7 read math and history. 6 read math and English. 8 read English and history. All the students read at least one of the 3 subjects. Draw a Venn diagram to illustrate this information. Then A. How many students read math only? B. How many students read English only? C. How many students read history only? Then D. How many students read 2 subjects only? So, let's start by first picking up the most important information from this question. In this class, we have 3 main groups of students. We have those that read maths, those that read English, and those that read history. So we would represent maths with capital M, English with capital E, and history with capital H. Again, we are told that in this class there are 45 students. What this means is that our N universal will be equals to 45. 24 of these students read math. So number of math students is 24. 20 of these students read English. So therefore number of English students is 20. 22 of them read history. So number of history students is 22. Also, 3 students read all the 3 subjects. 7 students read math and history. 6 students read math and English. 8 students read English and history. Again, from the question, we are told that all students read at least one of the 3 subjects. What this means is that we do not have any student in this class who do not read any of the subjects. So we've been able to get the most important information from this question. Let's rewrite them on a fresh page and use them to draw our Venn diagram. So our solution. So these are the information gathered from the question given to us. First, our total number of students, which is equals to 45. The number of students reading maths, which is equals to 24. The number of students reading English, which is equals to 20. The number of students reading history, which is equals to 22. We then have math intersection English, which is equals to 6. Then English intersection history, which is 8. Also, math intersection history, which is 7. Then those reading all subjects is 3. Let's draw our Venn diagram of 3 intersecting sets. Each circle in this Venn diagram would represent a set. The universal set will be represented by the rectangle. The circle on the top left would represent math, which is equals to 24 students. The circle on the top right would represent English student, which is equals to 20. And the circle at the bottom would represent history students, which is equals to 22. The total number of students, which is n universal equals to 45, would have to be written by this Venn diagram. Now, the number of students who read all 3 subjects is equals to 3. So let's write this information at the appropriate region of the Venn diagram. Now we are told that M intersection E is equals to 6. But let's first identify M intersection E region. This region is M intersection E. It represents students who read math and English at the same time. As you can see from the Venn diagram, there are 2 regions in this region M intersection E. One of the regions has 3 students. The other region, we do not know the number of students there. Assuming we are asked to find the number of students in that particular region, how do we do this? The clue is this. Remember, that whole region is represented by 6, that is M intersection E. So if we subtract the region 3 from the 6, what it means is that the remainder should be 3. So let's fill that information there with 3. Again, we are told that the region E intersection H is equals to 8. Let's first identify this region E intersection H. So this is the region E intersection H, the intersection of English and history students. Now, the region English intersection history has 8 students. It is also divided into 2 main regions. The first region has 3 students, but we do not know the number of students in the second region. But we can find this, can't we? If that whole region is equals to 8 and a part of it is 3, what it means is that the remaining of it should be 8 minus 3, which is 5. So we would have to write 5 there. Next, M intersection H is 7. Let's first identify the region M intersection H. So this is the region M intersection H, the region where students read math and history at the same time. We know 7 students are in this entire region. We can also see from the Venn diagram that this region has 2 main regions. The first part has 3 students. The second part we do not know, but we can find this because we know that that whole region has 7 students. So if the take out the portion we know, which is the 3 from the 7, you will get 4. So that means that the unknown region will be 4 students. So let's write that information. Now there are 3 more regions we've not labeled yet because we've not been given any value to assign to these regions. So what we will do is this: we will represent those regions with alphabet or variables. So that's what we are quickly going to do next. The first region is M only. So let's assign the variable small m at that region, M only. The second region is E only. Because we've not been given anything to represent this region, we would assign it by the variable small e. Then we have the region H only. So we would assign the variable or the alphabet small h for this region. Let's still remember that because in the question we were told that at least all of these students read one of the subjects. What this means is that there is no student who does not read any of the subjects. So we will not have the situation where we have a number in the rectangle which is also outside the 3 circles. We can't have anything like that. So this is the Venn diagram we are going to use to solve our problem. And we're going to move this Venn diagram to a clean sheet and we'll use it to solve the various problems given to us. So we now have our Venn diagram on a fresh page. Our first question is asking how many students read maths only. Now we've represented math only by the variable m. To be able to find this variable m, it is important for us to look for a relationship in which m, or a mathematical relationship in which we find m. How do we derive this mathematical relationship involving the variable m? When you look at the Venn diagram closely, you realize that the variable small m has a mathematical relationship with the bigger M, which is the set M. Now, let's first identify the set M. So, this is the set M. The relationship that the variable M has with the bigger M, the set, is now very clear. You realize that the small m plus 4 plus 3 plus 3 is equals to the bigger M, which is 24. So this is the relationship that exists between the small m and the big M. Remember that the big M is equals to 24. Now let's solve this equation mentally. So we have m plus 3 plus 3 plus 4 equals to 24. When you add 3, 3, 4 together, you would get 10. So you'd have to move the 10 to the right side of the equation and it to be subtracted from the 24. So 24 minus 10 will give us 14. That means that the value of m is 14. Therefore, the number of students who read only mathematics or math is equals to 14 students. Let's look at the second question. How many students read English only? Again, we've represented English only by the variable small e. So we'll look for a mathematical relationship in which we will find the variable e. You would also realize here that the variable small e has a mathematical relationship with the set E, that's the big E. This is our set E. So now the relationship between the small e and the big E is very clear. We have 3 plus 3 plus 5 plus e equals to the big E, which is also equals to 20. So let's write the relationship down. So that is 3 plus 3 plus 5 plus e equals to 20. Let's solve for the value of small e mentally. So 3 plus 3 plus 5 would give us 11. We would move 11 to the right side of the equation to become negative 11. So subtract the 11 from the 20 and that would give us 9. So our e is equals to 9. Therefore, 9 students read English only. Next question. How many students read history only? History only is being represented by the variable h, small h. Again, you'd realize that the small h has a mathematical relationship with the big H. So this is our big H, the set H. The relationship is now very clear. We have 4 plus 3 plus 5 plus H equals to the big H, which is equals to 22. So let's write that relationship down. So that is it. We have 4 plus 3 plus 5 plus the small h equals to 22. Let's solve for the small h mentally. So we have 4 plus 3 plus 5. That will give us 12. We move 12 to the right side of the equation. It will become negative 12. So we would have to take the 12 out of the 22. That would give us 10. So our h is equals to 10. Therefore, 10 students read history only. Our next question. How many students read 2 subjects only? We would first identify the regions that represent 2 subjects only. So these are the regions that represent 2 subjects only. We would therefore need to add these numbers together to get the total number of students who read 2 subjects only. So we would add 4 plus 3 plus 5. And when we do the math, we would get 12. Therefore, 12 students read 2 subjects only. Let's look at example 3. Example 3. In a class, 30 read biology, 21 read chemistry, and 22 read physics. 15 read biology and physics. 10 read chemistry and physics. 13 read biology and chemistry. 2 read physics only. 3 read chemistry only. And 7 read biology only. All the students read at least one of the 3 subjects. Draw a Venn diagram to illustrate this information. A. How many students read all the 3 subjects? B. How many students are in the class? C. How many students read only 1 subject? And D. How many students read 2 subjects only? So, as usual, let's pick the most important information from the question. Now, from the question, we would realize that 3 main subjects are being read by the students. So, you have students reading biology, those reading chemistry, and those reading physics. So, we'll represent biology by capital B, chemistry by capital C, and physics by capital P. We are then told that 30 of the students read biology. So let's write this information down. 21 of these students read chemistry. So let's write this down. 22 of these students read physics. So we'll write this also down. Again, from the question, we are told that 15 of the students read biology and physics. So let's write this down. So biology intersection physics is equals to 15. Again, 10 of the students read chemistry and physics. This would represent chemistry intersection physics. So let's write chemistry intersection physics equals to 10. From the question, 13 of these students read biology and chemistry. So that means that biology intersection chemistry is equals to 13. Again, we are told that 2 of these students read physics only. So let's write physics only down. 2 of these students read this subject only. For those who read chemistry only, they are 3 in number from the question. So let's write this also down. We are then told that 7 of these students read biology only. So we need to write this also down. So let's do that quickly. Also from the question, we are given this important information that all the students read at least one of the 3 subjects. What this means is that we do not have any of the students who did not read any of the 3 subjects. So let's note this information. The question then went ahead to ask us to find the number of students that read all 3 subjects. Because we do not know this number, we would represent this by the alphabet or by the variable x. So all subjects or all 3 subjects will be equals to x. Let's write this information down. The question also asked us how many students are in the class. So here we are being simply asked to find the total number of students in the class. So let's represent this by y, since we do not know the total number of students in the class. And let's remember that this is the same as the universal, the total number of people in the universal set. So n universal will be equals to y. So now that we have the most important information from the question, let's move them to a fresh page and use them to solve our problem. Now let's look at the solution. We'll first write the most important information regarded from the question here and would use them to solve our problem. So 30 of these students read biology, 21 of them read chemistry, 22 of them read physics. For those who read all three subjects, we do not know, so we've represented this by the variable x. Biology intersection chemistry was 13. Biology intersection physics was 15. Chemistry intersection physics was 10. Physics only was 2. Chemistry only was 3. Biology only was 7. Finally, we represented the total number of students in the class by the variable y. So we'll first use the following information to construct a Venn diagram of three intersecting sets. So this is our Venn diagram of three intersecting sets. The rectangle represents the universal set, whilst the three circles represent the three main subjects that were read by the students. The total number of students in the class was y, so write this information by the Venn diagram. The circle on the top left represents the student that read biology, so represented by b equals to 30. The circle on the top right represents the student who read chemistry, so it would represent this by c equals to 21. The circle at the bottom represents physics students, so it would represent this by p equals to 22. Those who read all three subjects were represented by x. So let's first identify that region and write the value x in that region. So this region colored red is the region that represents students who read all three subjects, and we have represented it by the variable x. Now let's locate the region biology intersection chemistry, which is equals to 13. This is the region biology intersection chemistry. Now this entire region has 13 students. But let's also note that from the Venn diagram, there are two regions in this region. First, we have the red region, which is represented by x, and we also have the blue region. We know the number of students in the red region to be x, but we do not know the number of students in the blue region. How do we find this? It's very simple. If that whole region is 13 or has 13 students, to find the number of students in the blue region, we just subtract the red part from it. So we would have to subtract x from 13 to get the number of students at the blue region. So let's quickly do this. Next, let's look for the region biology intersection physics. This is the region biology intersection physics. There are 15 students in this entire region. What we would also need to note is that this region has two main regions, the red region and the blue region. We know the red region to be x, so to find the blue region, all we need to do is to subtract the red part from the whole region, which is 15. So we'll subtract x from 15 to get the number of students at the blue region. So let's quickly do this. Next, we'll be looking at chemistry intersection physics, which is equals to 10. First, this is the region that represents chemistry intersection physics. There are 10 students in this region. The Venn diagram also shows that there are 2 regions in this region. First, the red region that has X number of students, and the blue region, the number of students we do not know. So to find the number of students in the blue region, we have to subtract X number of students at the red region from the whole region, which is 10. So the blue region will give us 10 minus X. Next, let's look at the region that represents physics only. This region with the number 2 represents physics only. Remember from the question, 2 students read physics only. We know that 3 students read chemistry only. So let's write the number 3 at the appropriate region. So the number 3 would be in this region. That is the region for chemistry only. Finally, 7 students read biology only. So would represent biology at the appropriate region. This region represents biology only, and that's where we should write the number 7. So we've now been able to draw our Venn diagram. Let's use our Venn diagram to solve the rest of the questions. Let's look at the first question. How many students read all 3 subjects? Solution. So first we'll draw our Venn diagram and then use our Venn diagram to answer this question. That is our Venn diagram. Now we also know that we've used the variable x to represent the number of students that read all 3 subjects. So what this means is that we would have to find the value of x to be able to answer this question. How do we find the value of x? This is very simple. For us to be able to find the value of x, we would have to look for a mathematical relationship in which x can be found. Then we can use that relationship to arrive at the value of x. So let's look at how we can do this. Let's take the circle representing biology. This circle has 4 different regions. The first region is the red region, represented by the variable x. The second region is the region above the red region, which is represented by 13 minus x. The third region is represented by 15 minus x. And the final region is represented by 7. What this means is that when all these 4 regions are added together, we would have to get 30. So that's exactly what we are going to do. We are going to add all these 4 regions together and equate whatever answer we are going to get to 30. So let's quickly do this. So we have the region 7 plus the region 13 minus x plus the region x plus the region 15 minus x, and we will equate all of them to 30. At this point, we have a simple linear equation to deal with, and from this simple linear equation we can find the value of x. So let's find the value of x from this simple linear equation. From this equation, you would realize that our negative x plus x would give us 0. So let's ignore that whole expression. Our linear equation is now easy to deal with. So we now have 7 plus 13 plus 15 minus x equals to 30. Let's write that new expression down. 7 plus 13 plus 15 will give us 35. So we now have 35 minus x equals to 30. So at this point, we would have to group like terms. So we would have to move the negative x to the right side of the equation, and it will be positive x. We would also move the 30 to the left side of the equation, and it will be negative 30. So we therefore have 35 minus 30 equals to x as our new linear equation. 35 minus 30 would give us 5. So therefore x equals to 5. Now that we know the value of x, we can conclude that 5 students read all 3 subjects. Let's move on to question B. Question B. How many students are in the class? Solution. So first, let's draw our Venn diagram. Let's also remember that the question is asking us to find the total number of students in the class. That is the value of the y. So what we would have to do is to add all the regions on the Venn diagrams together to arrive at this answer. Before we do this, let's remember that we've already been able to find the value of x, and the value of x is 5. So we are going to replace the x on the Venn diagram by its actual value, which is 5. What this also means is that all the other regions on the Venn diagram with x would also have to be replaced by the actual value of x, which is 5. So the region 13 minus x would be 13 minus 5. 13 minus 5 is 8. So let's write 8 at that green region. In the same way, the region 10 minus x will be 10 minus 5, since the value of x is 5. 10 minus 5 is 5. So let's write 5 at that yellow region. Also, the region 15 minus x will be 15 minus 5, since the value of x is 5. 15 minus 5 is 10. So let's write 10 at the blue region. At this point, all the various regions of the Venn diagram have their numbers. So all we need to do is to add them together to get the total number of students in the class. So we have 7 plus 8 plus 5 plus 10 plus 3 plus 5 plus 2, and we would add all of these regions together to get the total number of students in this class. When we do this well, we would get the value of y to be equals to 30. Therefore, the total number of students in the class is 30. Let's look at question C. Question C. How many students read only one subject? Solution. So we'll first draw our Venn diagram. Let's now solve the problem. This is very easy. So all we need to do is to locate the regions where students read only one subject and add those regions together to arrive at our answer. The regions where students read only one subject are the region 7, the region 3, and the region 2. So we'll add 7, 3, and 2 together to arrive at our answer. 7 plus 3 plus 2 would give us 12. Therefore, 12 students read only one subject. Let's look at question D. Question D. How many students read only 2 subjects? Solution. So we'll first draw our Venn diagram. To find the number of students that read only 2 subjects, you will need to find the regions on the Venn diagram where students read only 2 subjects and add those numbers together. As you can see from the Venn diagram, the regions green, yellow, and blue are the regions where students read only 2 subjects. So we would have to add those numbers in these 3 regions together to arrive at our answer for this problem. Therefore, we have 8 plus 5 plus 10. We'll add these numbers together to get the answer. When we do this, we would get 23. Therefore, 23 students read only 2 subjects. Let's look at example 4. A group of students were asked whether they liked apples, bananas, or corn. Their responses are shown in the table below. Draw a Venn diagram to illustrate this information. A. How many students liked apples only? B. How many students were in the group? and see how many students liked exactly 2 fruits. In this question, the most important information needed to solve it had already been provided on a table, so we do not need to get this information. We just pick them from the table and use them to complete our Venn diagram. But we still need to remember that we have 3 groups of people in this class. We have those who would eat apples, those who would eat bananas, and those who would eat corn. So we would represent apples by A, capital A, bananas by capital B, and corn by capital C. Let's move this table to a fresh page and use it to complete our Venn diagram. So let's look at the solution to this problem. Let's first draw our table. We would then draw our Venn diagram of 3 intersecting sets. The circles in the Venn diagram would represent the main groups in the class: those that eat apples, those that eat bananas, and those that eat corn. The circle at the top left would represent those that eat apples. The circle at the top right would represent those that eat bananas, and that below would represent those that eat corn. The rectangle of the Venn diagram would represent the total number of students in the class, that is the universal set. So now let's use the information on the table to complete our Venn diagram. First, we are told that 7 students liked all 3 fruits. So let's show that on the Venn diagram. So that is the region. We are then told that 11 students liked apples and corn. Now this region represents those that like apples and corn. And we also know that the number of students that represent this region, A and C, or A intersection C, is 11. We can also see from the Venn diagram that A intersection C has 2 regions. The first region we know, that's the red region that has 7 students. The second region we do not know. So to find the second region, all we need to do is to subtract the red region 7 from that whole region, which is 11. When we do this, we would get 4. So let's fill that region with the number 4. Next, we are told that 9 students liked corn and bananas. This is the region that represents corn and bananas. At this region, the students like corn and bananas. We also have a total of 9 students in this region. The Venn diagram also shows that there are 2 regions in this region. The first region is the red region, and we know this region has 7 students. The second region we do not know, but we can calculate this by subtracting the 7, which is the red region, from the total region, which is 9. When we subtract 7 from 9, we will get 2. So that means that the unknown region has 2 students. So we'll write 2 students in that region. Let's look at the next item on the table. Here we are told that 10 students liked apples and bananas. This is the region that represents students that liked apples and bananas. We can also see from the Venn diagram that this region A and B has two regions. The first region, which is the red region, we know its value to be 7. The second region we do not know, but then we can find this also because we know the number of students for that whole region to be 10. So to find that region, all we need to do is to subtract our 7 from the 10, and that will give us 3. So we would have to write 3 in the unknown region. Let's write the next important information on the Venn diagram. Here we are told that 34 students liked apples. If 34 students liked apples, then what it means is that our A will be equals to 34. So let's write that information down on the Venn diagram. Let's move to the next item on the table. We have corn only, and we are told that 18 students liked corn only. So now let's look for the region on the Venn diagram that represents corn only. This region, the yellow region, represents corn only. 18 of these students liked corn only. Next item on the table is banana only. This region is for students that eat banana only. These students are 16 in number. The next item on the table is telling us that 3 of the students liked none of the 3 fruits. I believe we know which part of the Venn diagram that this group of students would be. Remember, these students like none of the fruits, so they will be outside the 3 circles. But let's note also that they are members of the class, so they should be in the rectangle. So whilst they are in the rectangle, they will be outside the 3 circles, so they will be represented by this region. So we've been able to draw a Venn diagram showing all the important information given to us on the table. Now let's use our Venn diagram to answer the questions that were presented to us. Our first question: how many students liked apples only? Let's look at the solution. We would first draw our Venn diagram. So that is our Venn diagram, and we are going to use it to answer this question. First, let's identify the region apples only. We will then represent it by the variable small a. This white region is apples only, and we've represented it by the variable small a. How do we do this? To be able to do this, we have to look for a mathematical relationship in which the variable a can be found. Once we are able to do this, we can find the value of the variable a. Can you see any mathematical relationship from the Venn diagram? Yes, I can see something like that. That is the relationship between the small a and the whole set A. First, let's select the entire set A. So this is the set A. From this Venn diagram, you'd realize that the small letter a, which is the variable, plus 3 plus 7 plus 4 would be equals to the big letter a, which is 34. So let's write that mathematical relationship down. So that is the mathematical relationship: a plus 3 plus 7 plus 4 equals to 34. From this linear equation, we can add 3 to 7, then to 4, and that would give us 14. So we will now have a plus 14 equals to 34. We will then move the 14 to the right side of the equation, and it will become negative 14, and we will subtract that 14 from the 34. 34 minus 14 would give us 20. So therefore a is equals to 20. Since a represents the number of students that like apples only, we will therefore conclude by saying that 20 students like apples only. Let's look at the next question. Our next question: how many students were in the group? So here we are required to find the total number of students in the entire group. So what this means is that we have to add all the various regions in the Venn diagram together to be able to arrive at this answer. Well, let's look at the solution. So first we will draw our Venn diagram. Let's also remember to write the value of a only in this Venn diagram. Remember, we solved for this value in our question before this particular question. So let's write it in the Venn diagram. It was 20. At this point, we can add all the various regions within this Venn diagram to arrive at our answer. So let's quickly do this. So we have 20 plus 3 plus 7 plus 4 plus 16 plus 2 plus 18 plus 3. So that will be equals to what? That would give us 73. Therefore 73 students are in the group. Let's look at our next question. This question is asking us how many students like exactly 2 fruits. Our solution: first we'll draw our Venn diagram. We would then identify the various regions of this Venn diagram where students liked exactly 2 fruits. In other words, only 2 fruits. So these are the regions on the Venn diagram where students like exactly or only 2 fruits. The blue regions. So we would have to add the numbers together to get our answer. So let's quickly do this. We have 4 plus 3 plus 2. That would give us what? That would give us 9. Therefore, 9 students liked exactly 2 fruits. Well, friends, this brings us to the end of part 7 of set and set operations. Part 7 marks the last part of set and set operations. In our next meeting, we are going to look at a completely new topic. We are going to mainly focus on bearings and vectors. Bearing and vectors is another very interesting topic, and I hope to meet you in class in our next meeting. Thanks very much for staying with us, and please subscribe for this channel if you have already not done that. We need your subscription for the continuation of this program. Also, once you subscribe and we make or come up with new videos, we will get you alerted. Thank you. Stay safe until we meet again in the next video.